So the first part of our second module is going to deal with the properties of water. So what we have listed here is we have that water is a polar molecule. It undergoes cohesion and adhesion, has a high specific heat, density greatest at 4 degrees Celsius, and is the universal solvent. So let's talk about some of those more in depth. First up, we have the polarity of water. In a water molecule, two hydrogen atoms form a single polar covalent bond with an oxygen atom. That gives water more structure than other liquids. Because oxygen is more electronegative, the region around the oxygen has a partial negative charge. The region near the two hydrogen atoms has a partial positive charge. A water molecule is a polar molecule with charges opposite ends of the molecule. So they have opposite charges. So this polarity is actually going to be a very important property of water because polar substances are going to dissolve in other polar substances. So when we are trying to dissolve things in water, there's going to have to be a polarity to them. And what that means is if you have salt, sodium and chloride, sodium is positive, chlorine is negative. When you dissolve that in water, the oxygen end is going to wrap around the sodium, and the hydrogen end is going to wrap around the chlorine. And this is going to be called spheres of hydration. Now, this polarity is also important because if you think about it, if you spilled salad dressing on your shirt and you just tried to clean it out with water, it's not really going to do a great job because that oil in the salad dressing is not going to dissolve in the water. So you're going to need another non-polar substance to dissolve it. That's why you use, dish detergent or laundry detergent or something that is non-polar to dissolve the oil in your salad dressing. Surface tension is a measure of the force necessary to stretch or break the surface of a liquid. It's related to cohesion. Water has greater surface tension than most other liquids because hydrogen bonds among the surface water molecules resist stretching or breaking the surface. Water behaves as if covered by an invisible film. Some animals can stand, walk, or run without breaking the surface. So we see right here a little bug that is able to stand on the surface by distributing its weight far enough and it's light enough that it doesn't break that surface tension. We all have seen an example of surface tension in action if we see somebody do a belly flop, or usually it's an accidental belly flop or hit their back on the water when they hit hard and we get that giant clap. And what that is it hurts. The reason it hurts is because you're breaking the surface tension of the water. All right. So there's an example that I always use from Fast and Furious 5, where Paul Walker and Vin Diesel are robbing the train and their car jumps off the cliff. Now, at that height, we know that hitting the water should kill them, but there's actually some science there. I don't think they intended it, but they did. When they jump out of the car and have the car hit the water first and follow it, what the car does is it hits the water and disrupts the surface tension, causing there to be ripples and little waves. So when they hit the water, the surface tension has already been broken. We see the same principle in, we just had the Winter Olympics, or when we do have the Winter Olympics, the ski jumpers, when they practice in the summertime, what they'll do is they'll jump into a swimming pool, but they don't jump into just a regular swimming pool. What it is it's got like bubblers and frothers and all that, so that the surface of the water is all bubbly like a hot tub. And because that, the surface tension is very low, so they do not get hurt when they hit that. So we do see surface tension quite a bit. Cohesion, water molecules tend to stick together, causes surface tension. Cohesion is when water molecules stick together. Adhesion is water molecules sticking to charged molecules. So the combination of the cohesive and adhesive forces lead to the capillary action movement of water through a tubular-shaped structure. So cohesion is what leads to surface tension. Adhesion is, we see right here, the tubular-shaped structure, drinking through a straw, something like that. It's sticking to the charged molecules. It's how you're able to pull up through the straw. Right? It's a combination of both, but adhesion leads to that, whereas cohesion, we're talking about surface tension. Specific heat is the amount of heat that must be absorbed or lost by 1 gram of substance to change its temperature by 1 degree Celsius. So 3/4 of the Earth is covered by water. The water serves as a large heat sink responsible for the prevention of temperature fluctuations, coastal areas having a mild climate and a stable marine environment. So basically, what that's saying is that there's a lot of heat that has to go in before water can really change, right? And we see right here on this slide, water has a high specific heat. So because of that high specific heat, it can absorb a lot of temperature and keep things more milder. So that's why we see less snowfall in areas that are on the coast as compared to more inland areas, okay? Because that water absorbs a lot of the heat. Now, we also got to look at things like salt water and all that, and that's that high specific heat is going to absorb a lot. But we can also use that for evaporative cooling. The cooling of a surface occurs when liquid evaporates. So we see this a lot, and one of the things that you might see is in the summertime during football training camps or something like that, football players will be wearing long sleeve shirts and long tights. And you think, well, it's so hot out. Why would they do that? And when you're wearing those heat gear shirts by Nike or Under Armour, or whoever happens to be making it, what those are actually going to do is that's going to keep the moisture on your skin. When you're sweating and, you just have, a tank top or something like that, the sweat's going to fall off your arms or evaporate quickly. Whereas these shirts will actually hold that moisture close to your skin. And because it's close to your skin, it's absorbing a significant amount of that heat, thus keeping you cooler while you exercise. The solvent for life. So it's solution versus solute versus solvent, all right? An aqueous solution, we're going to deal with when we're talking about water. Hydrophilic is when ionic compounds dissolve in water, all right? Hydrophilic, they're things that are going to be polar molecules. They're going to dissolve in water, whereas hydrophobic would be something like oil. It's a non-polar compound that's not going to dissolve in water, and that's what we just talked about. So let's talk about that a little bit more. Hydrophilic substances are anything that is attracted or dissolves in water. They are substances that are charged and polar, so they're things that are going to dissolve in water. We're going to see that when we do lipid bilayers. Hydrophobic substance is anything that does not dissolve in water or is not attracted. So some substances that are not charged, non-polar. So oil, all right? Oils, that's why you have to shake salad dressing so vigorously when you take it out of the refrigerator, is because the oil and the water have separated. Solubility is the maximum amount of solute that dissolves in a specific amount of solvent. So solute would be the thing being dissolved. Solvent would be the thing it's dissolved into. So if we were using salt water as the example, the solute would be the salt, the solvent would be the water. Temperature sensitive for solutes, expressed as grams of solute per 100 grams of solvent, usually water. So we have grams of solute over 100 grams of water. Unsaturated solutions contain less than the maximum amount of solute, can dissolve more solute. So more things can be dissolved in. Whereas when we look at a saturated solution, we're going to contain the maximum amount of solute that can dissolve, have undissolved solute at the bottom of the container, contains solute that dissolves as well as solute that recrystallizes in an equilibrium process. And a saturated solution, more solute can dissolve in an unsaturated solution, but not in a saturated solution. So that makes sense. When something is unsaturated, more can go in. When it's saturated, when it's fully saturated, nothing more can go in.